Okay, good afternoon everybody. Firstly, welcome to Nottingham and welcome to the Department of Electrical and Electronic Engineering. My name's Steve Grady and I'm part of the admissions team along with Mark Sumner, and we deal with everything involved in receiving your application through to the interview process to processing the offers. Okay, so we're the team involved in that here within the department at Nottingham University. So what we intend to do is really give you an introduction to the courses that we offer today, and also lead into a few opportunities that are on offer to you whilst you study here at Nottingham University. Okay, so I'm going to cover the course. The purpose of the day is to find out about the course structures. I'm not going to ask for people to ask questions during this session. What I want you to do is think of questions as you listen to what's said through this morning. Take those questions to the lunchtime session and maybe use them to inform any questions you want to ask through your interview. Okay, so it's to tell you about the courses, your study environment. We'll touch on employment prospects, bit on student life. Really, the student life will come through your discussions with the student ambassadors over lunch. And the thing you want to go away with today is, could you see yourself studying here? Okay, could you see yourself living within Nottingham for the next 3-4 years while studying here? Okay, and then I'll go on to tell you a bit what happens next following today's activities. So program introduction to our courses. Once we finish talking to you, introducing the courses and everything we have to offer, we've got a taster lecture given by one of our academics, Kevin, who's going to come in and talk about something related to his area of research. We'll then break around about 1 o'clock if we're running to time, where we'll go over to lunch, and during lunch there'll be lots of academics and students around for you to ask questions of. Then we'll end lunch and then we'll send you off to your interviews and to have you look around the department while we keep your parents and accompanying guests in the room we have lunch in, and me and Mark will have an informal Q&A session with you in there. Okay. One note on the interviews. The interview's about gaining an understanding of your motivation to study electrical and electronic engineering. It is a lot of effort involved in studying an engineering degree, so we want to understand what is motivating you to want to make that effort to leave university with a good degree at the end of 3 or 4 years. Okay, so it's all about your motivation. We're not going to ask you lots and lots of technical, challenging questions. It's really for you to tell us what is motivating you to want to study at Nottingham, the subject of electrical and electronic engineering. And it's also an opportunity for you to ask the academic who will be performing your interview lots of questions about the course itself in a bit more detail. Okay. What will happen next, following on from today, I will gather the feedback from your interviewers. I will look at that feedback alongside your UCAS application, and that will allow me to finalise the offer that we would send out to you, which should appear on your UCAS track system within 7 days or so following today's activities. Okay. If you get to a point where you're worried nothing's happened, then please feel free to contact me directly. Okay. So I'm going to talk a bit about our courses before I hand over to a few other people. So why study EE at Nottingham? Well, it's a buoyant electronics industry, and that's really driven now by the desire for smart connected devices. So these smart connected devices enable access to vast amounts of data, enable systems such as Internet of Things based systems. They enable current and future communication technologies, and also feed in a lot of new technology into the provision of healthcare these days. Okay, so that's the electronic side of things. When we think about the electrical side of things, then really the electrical industry, which is very short of electrical engineers at the moment, is driven by the desire for renewable energy sources that provide energy to our domestic systems. We need to manage the delivery of that energy after it's generated into our domestic and industrial situations. But also looking forward to the future, we're looking really for everything to be driven essentially through electric technologies. So transportation is moving to more and more electrification, electric technologies as we move towards a greener future. Okay. So what I study at Nottingham, we are a research-led institution. All our academics are research active, which means that they can bring that research experience into their teaching. Which means that our teaching is delivered at the state of the art. The research experience they have outside of the lecture theatre is then brought into the lecture theatre to support the fundamentals that they teach. Okay, so our teaching is inspired by our research. Because we're research active, we have a lot of excellent links with industry, and again, that brings information into our teaching spaces as well. So we use the information that we gain from working with industry, and we also bring that into our teaching environment. All that combined leads a graduate from Nottingham University to have very good career prospects that are really enabled through the way we teach, through our course and our approach to developing, at the end of our course, real-world engineers. Okay, and we have a flexible program. What this means, I'll go on in a bit more detail of that later on. So essentially, we allow people to change their mind on their degree path up to the end of year 2. Okay, so that's one of the key things about our course. We're not expecting anybody to commit themselves to a course of study from day 1. You have 2 years to understand what your interests are, where your skills lie, and what you want to do as a future career, which will be supported by your choice in degree program. Okay, and we also offer an IET accredited program. Okay. Our entry requirements, there is a range of entry requirements. For A-levels, they range between 3 A's and an A and 2 B's. That allows us to tailor the offer that we make to an individual set of circumstances. So part of today's activities will provide me with information that will enable me to tailor our offer to the individual. And we also accept the equivalent of 3 Ds at BTEC as well. Okay. So the courses we offer, electrical and electronic engineering, that's the combined program, electronic engineering, electronic with computer engineering, and electrical engineering. But the way we deliver the course allows you to swap between any of those up until the end of year 2. So our courses throughout our years are designed initially to inspire, then to develop your skills, and then to specialise in areas of interest later on in the course. So the course structure for years 1 and 2. Year 1 is common for all courses, where we develop your fundamental scientific and mathematical skills. We develop essential practical skills through project-based work. And just to emphasise, within our degree course, there is a significant amount of project-based work, which I'm going to go and touch on in a few moments. Year 2 follows a similar pattern, but this is where we take the fundamental skills and knowledge that you developed in year 1, and then we push them to a more advanced level. So first year content designed to inspire you. 50% of it is based within a lecture environment such as this, where you have an academic presenting to you, or small group workshops, and we cover the subject areas of information systems, which is the more electronic systems, power and energy systems, which are the electrical engineering subject areas, and engineering analysis, which is coverage of the mathematical subjects that are important to you as engineers. So that's 50% of year 1 spent in a lecture type environment. But on the other side of that, 50% of your time would be spent in a lab type environment, which you will see as part of your tours later on. Within these lab-based situations, we cover applied engineering design approaches. So that's posing problems that you will come up with solutions by applying your own imagination, your own ability to go off and research information to develop a solution to the problems that we pose. Okay, it's not an instruction-led lab-based exercise. It's we pose a problem, you have to go off and design a solution to the problem that we pose. And also we spend a fair amount of time in computer-based labs where we develop our software engineering skills. So this is a schematic overview of our structure for year 1. It's very similar for year 2. So we arrive in Welcome Week. This is what commonly referred to as Freshers Week, where we get everybody together, and that's where we start to introduce you to each other, break the ice, but we do drop you in the deep end, and within 2 days of that Welcome Week, we ask you to build a small computer-controlled car that will support your learning throughout the rest of the year. Then we have a week introductory lectures where you're introduced to each of the topics that we will cover, that we will teach you. And then second proper week here at university, you're into a project lab. So that's 9 to 5 every day, you're in a project lab to come up with a solution to a problem that we pose from day 1. Okay, so it really is dropping people in the deep end to develop their engineering way of thinking and to develop their real-world engineering skills that are desirable by industry. Okay, so here we have you working on a small four-wheel drive vehicle to get that up and running over the course of a week, where you work in small teams of 4, to come up with a solution to that problem that we've posed. Break for a few weeks of teaching, back in the project lab. Then we break for a few more weeks of teaching, back in the project lab, etc. That pattern carries on through the end of the year, and at the end of the year we end up with a couple of exams to finish. So we do only have a couple of exams at the end of year 1. Most of the assessment is done through coursework that will pick up on the subject areas that we're teaching, and also elements of what you do in the project lab. Okay, so that's all assessed through coursework through to 2 exams at the end of year 1. The end of year 2 has a few more formal examinations built in, but the pattern of teaching is more or less the same. So what we do in year 1 in terms of the project, we have students build up this small vehicle, four-wheel drive vehicle, from scratch. There's a lot of practical effort required in there. There's skills you have to pick up for test and measurement. It won't necessarily work the first time. It encompasses electronic engineering, electrical engineering, and also computer engineering, because you have to program the vehicle's controller to allow the vehicle to do what it needs to do. All the wheels are independently driven. The wheels won't necessarily move at the same rate, given the same input, so you have to control those wheels to make sure that vehicle can follow a path that you want it to. The vehicle is modular, allows all 4 people to contribute to, so it's not one person doing all the build, but it's a development platform that allows you to build systems on top of that platform to make the vehicle, ultimately over 7 weeks you will spend in the lab, an autonomous vehicle that's able to navigate through an environment using a computer vision based system. So we equip the vehicle with a camera, allows it to see its environment and perform tasks and navigate through that environment after 7 full weeks of activity. So just a couple of images. So end of week 1 we'd have a competition, and this is a straight line 10-metre drag race. Everybody gets to see how quickly their vehicle can race over 10 metres, but it has to stop on the 10-metre line exactly. If it doesn't stop exactly on the 10-metre line, then it doesn't count. So we want both the speed and the ability to accurately stop on the 10-metre line. That's the challenge at the end of the first week, which is not as easy as it sounds. And then through all the other weeks we're building up to a vehicle, including more and more technology on it to make it as autonomous as possible. So this is the course we used last year as the final course to navigate around. So the vehicles using a camera-based system will have to follow a line. They also have to react to signage around the course and perform tasks. One of the tasks was to knock a football into this goal. So it has to find the football using the information received through its camera, find that football, knock it into a goal. Okay? So what we are asking of first year students at the end of the year is to develop something that is quite complex and quite significant. So project weeks designed to develop practical skills, develop skills and troubleshooting skills, very important to engineers, and to experience both individual and teamwork within those environments. At times you'll work on your own subsystem, at times you'll have to work with everybody else in your group to integrate the subsystems onto the vehicle. So, just to give you a bit of a flavour for the atmosphere. So this is the first week where everybody's trying to get their vehicle working to complete the 10-metre challenge. So they're in the labs trialling everything out. Sometimes it works. One of the important things to take away from this is everybody at every level is involved in these activities. So there are people there from technical staff, through to student demonstrators, through to teaching assistants, people like me, the academics that run the lab, and also the head of department is also involved in these activities as well. So I'll stop there. So hopefully that will give you a bit of a flavour for what's going on. Everybody's having fun, everybody's taking part, but there's a lot of engineering knowledge being built up, a lot of skills being developed from day one on our course. So second year content is designed to develop you further as an engineer. So again, 50% lecture-based, 50% project-based. However, here on the project elements, we're looking deeper into how systems work. So we're looking into the systems in more detail and having you build solutions from scratch. Okay, so that's the key thing here. The vehicle, modular subsystem, so at times you're looking at that on a higher level. When we get into second year, you're really digging in a lot deeper using the knowledge you've built up over the first and the second year to really understand how things work. Course structure in years 3 and 4 is where you specialise. At the end of year 2, you have a bit of an idea of what really interests you, what really motivates you, and that's where you choose the subjects to match your interests through years 3 and 4. If you do a 3-year course, you will also be doing your final year project in the 3rd year. If you're doing the 4-year course, in the 3rd year you would do a larger group project that's delivered to us by industry, so we have to come up with a solution for an industrial partner. And if you're doing the 4-year course, in year 4, you would also be doing your final year project. Okay? But in years 3 and 4, that's when you really get to pick and tailor the degree to your own interests and needs. So some typical themes in years 3 and 4 put up here. I'm not going to go through all of them, but they're typical themes that you would find within an electrical and electronic engineering degree program. But there really is enough choice there to satisfy most needs that you would have at that point. Okay. So a bit on the major solo project. So at the final year of your degree, every student will undertake an individual design project. So up to that point, every project or piece of project work you do is undertaken as a group. When you get into final year, you undertake that project as an individual. Now that project can be taken from areas of active research that we have. It can be taken from industrial posed problems. Whoops. So, such as this wind turbine. So this is a real working wind turbine that's what's the word I'm looking for? Installed in our Sutton Bonington farming campus. So the students were there to take or make sure that we could control and deliver the energy generated by this wind turbine in a safe manner. It was in a working environment, a working farm environment. So we go from more research-led activities, which these 2 pictures are illustrating. So this is in the area of medical instrumentation, using lasers to measure very small observables, through to looking at radar systems within one of our research labs. If you want to work in robotics, we have plenty of kit to support those interests. So this could be that you come to university, you want to work in robotics, and you decide in your final year you want a project in that area. We can support that. Or you could come completely with your own ideas and write, I don't want to do anything that's related to your research. I don't want to do anything that's given to you by industry. I have my own ideas that are developed through my own imagination, and this is what I want to do. And as long as we have an academic that can support that, we will allow you to do that. So this chap here wanted to build a quadcopter from scratch. Now this was before the time that they were available to buy off the shelves from the likes of Amazon. So this is about 8 years ago now, 8, maybe 10 years ago. But we leave it up there as an example of what you can do. So you can really use your own imagination to develop your own project, and then we will support that. Okay. So I've quickly sped through that. So that's kind of the structure of our course, what we try to do. Want to build your fundamental knowledge year 1, advance that knowledge in year 2, and allow you to specialise in year 3. And through completing your final year project, that's what turns you into a real engineer. At the end of the day, you have sole ownership of that final year project from start to finish. So alongside the academic content of our course, there are a lot of opportunities available to you that will build that CV to make you more employable.